Welcome back. Um, Today I'm going to make something that's kind of ad hoc or hacky, however you want to call it. Basically, I'm doing an upgrade to my laser cutter, and long story short, I need to connect two hardware store 6-gallon buckets together, um, and they need to be connected below the lid, but also above the normal water line, but not above the safe water line. And to do that, I've got to drill holes in the sides, one hole in the side of each bucket. And I've got to stick in a fitting. And I went to the hardware store, got a fitting, no problem there. Two fittings, actually. Got some hose to match them, no problem there. And went to find something that would be a female match to the male thread on the fittings. And that's where the issue came in. They had things that theoretically should have matched up. Um, same same thread pattern written on the package. But when I went to try them, none of them fit together. I even tried other fittings, and it's like whoever made these made all of their male threads too big or made all of their female threads too small. There's just no way to force them together. Um, so, with that in mind, I did still buy the ones with the male threads that have the fitting I need to hook up to the hose. And I am going to make the female part of that. And while I'm at it, I'm also going to make, instead of making it flat face, like what I would have bought at the store, I'm going to make it a rounded face to match the bucket. And I'm also going to make kind of a sort of spacer for the other side that's rounded to match the outside of the bucket as well. So I started by making a new folder, throwing a single part in there. There's nothing in this part right now. And I also took some measurements of the bucket. And I'm going to go ahead and model that right away. So I'm not going to get into a lot of detail on this bucket. It doesn't have to be perfect by any stretch of the imagination. So I'm not going to do anything with the top. I'm not going to do a detailed model of the bottom or any of that. I'm just going to try to get basically just model the face that I'm working with. So set this to construction. That way when I click here and here, I can drag over here and work in diameters instead of radius. And let's see, measure the circumference and divide it by pi, so that gets me an outside diameter at the top. And just realized that I didn't measure the distance between the two, which was silly. So I will reach over here and just measure it real quick. So that's 296. And I measured along the face, so I want to go like that. So I'm measuring parallel with the line as opposed to just a regular vertical dimension like this. Not that it makes a huge difference here, but try to get it accurate. And then I am just going to, well, you know what? I am also going to be needing the inside of this. So I will draw these in. Make these horizontal. Make these parallel. Make these equal. Not that those particularly matter. In fact, I'm going to make them really tiny. And let's see. My material thick is 1.71. Alright, and with that, I can do a revolve boss. And, okay. That actually put a lid on it, so I'm going to go back and change that a little bit. Let's see if I go take those, say they're all for construction. Then I can go from here to there to there, and do a coincident, get out of the sketch. Now I don't have a lid on it, at least. Makes it a little bit easier to model. And I'll just click save. And then I'm going to do a new part again. And I'm going to click save. And I'm not even going to bother modeling up the whole fitting. I just need to model up enough of it that I can work with. So pull out the trusty Starrett digital calipers, and draw a general kind of sort of shape on it, and something like this, and like that, and up a little bit, out, and there, and then the fitting is up here. So since this is going to be a revolve, this is like looking at half of it. So I'm going to say vertical there, horizontal there, and there, and there, and there, and there. And this will be vertical as well this. Let's see this dimension. Let's see, probably could have made that as a diameter, but whatever. And this doesn't have to be super accurate on this side of it, but I just want to model it up to get so it's easier to visualize. So 20.68 is the diameter. So I'll just divide that by 2 to get a radius. And let's see. I'm going to try to go point to point on this. That way, actually, you know what? I'll go flat to flat. 28.72. Again, divide it by 2. And let's get the height of this. 24.58. And get the height of this. 644. And let's see, need a diameter for this. 2392 divided by 2. Drag this out. And all right. Now the height from here to here I can measure real easy. So might as well start with the easier ones. That's 14.57. And let's see. At the end I've got a diameter, but I don't really need to worry about that too much. Let me see if these threads are tapered or not real quick. 27.09, 26.93. So they're not tapered. The second measurement was actually further up, so if anything that should have been larger if they were tapered. So just measuring a few times in a few different places. So 27.07 seems to be about the average. And then this can be vertical as well. And let's see, how high are the actual threads? Or rather, how far is this? That's easier to measure, I think. Maybe. Either way, it's pretty hard to get in there. 2.14, 1.95, 1.95 is the lowest I got. It's not super critical there. So I'm going to select this, do revolve boss, and yep, that works. And this part's got to be threaded, and normally I wouldn't bother modeling threads, but I'm 3D printing this, so I actually have to model threads in this case. So first, let me get the inside diameter of these threads. And let's see, that's 24.02. All right, and let's see. Basically gonna start just making a couple of sketches almost to take notes. And normal to this one, and do a sketch, and make a triangle, which this part's gonna be vertical, this part is gonna be equal, and I do not really have a tool for measuring the angle on these. So what I can do is put a point on here and say pierce there. So that locks down this line. And this line, to do that, I can select this face and say intersection curve. And then I can coincident to that. And then I can just dimension the bottom of the thread if I can actually get my calipers in there, which it's hard to say if I can. Yeah, it's going to be hard to get my calipers in there. So let's delete this dimension. Kind of drag this to about right. I'm going to select this chain. And I'm going to do a linear pattern going up of 4 because there's 4 threads in a row. And I'm going to do a coincident there, or merge. Drag them. I'll fix this for the time being. Drag them down. And what's the dimension for all 4 of them together? Uh, 8.75. I'll try it again in another spot. Just try to get as accurate as possible. The way it is, it's really hard to get calipers in here. 8.8, it looks like. So that gives me that. I can real quick do a driven dimension. So it's some kind of, yeah, that might be why I couldn't get anything to fit with it. Because it's pretty far away from the 60 degrees, isn't it? That's alright, we'll make a matching thread, doesn't really hurt anything. And let's see here. I'm going to unfix this bottom one. Don't want that. I only wanted that fixed to help me dimension there. How far from the bottom does these threads start? So measure that. 2.24. Alright. So something doesn't quite. Oh, yeah, in one section there are 5 in a row. That would be why. And actually, that's the section where I just measured. So I will just add in one more. Make this parallel and equal. Make this parallel and equal. And there we go. And right. So it's hard to say Let me double check my measurements again. 2.06. So brings it down a little bit. I'm thinking maybe this measurement up here I didn't get quite right because I couldn't get the calipers all the way in there. That's fine. No big deal. So I'm going to exit the sketch and sketch here. I'm going to convert, extrude up to this vertex. Again, this is kind of a sloppy thing, but it only has to be good enough. Alright, then normal to this again. And I'm going to sketch on here. And I'm going to go and basically make the opposite of one of these. And make that actually a linear pattern going downward. It's only of one extra. I'm going to make this original one for construction. And it doesn't really matter where this starts. So as far as timing goes, I don't care about timing this. It can rotate and it can end up tight however it ends up. So I'm just going to say that this is one below. And alright, I'm going to take this and I select that. I say split, cut part, okay. That gets this out of my way. And let's see, what is our pitch? 2.2 millimeters. Alright, so I'm going to take this, say parallel, and coincident. Oh, sorry, wrong coincident. There. And I'm going to sketch on that plane that I just made. I say this is concentric, and this is coincident. Alright. And select that. Say I want a helix, and my pitch is 2.2. And I want to go upwards. I want it to be clockwise. Start angle, we'll set it at 0. Nope, that's the opposite side, so let me try it at 180. And that's where I want it to start. And then I can just set the revolutions higher. Let's see, I want to make sure it completely clears. So it starts well below, ends well above. And that works. So, I could move things around, but I don't want to risk anything screwing up, so I'm just going to make a new sketch, and I'm going to convert this sketch, and then I'm going to hide all these sketches. Use the sketch plus the helix to make a swept cut. And it might just give me an error about that. I think it's gonna. I think when it sweeps around, it's gonna hit the exact same spot here, and it's gonna say that's 0 thickness, even though it's cutting off the outside, so it shouldn't matter. It's gonna say that anyway. If it ever actually opens the feature up. Normally this shouldn't take this long, which is why I'm thinking that I made a mistake. And the most obvious mistake I can think of right now is that I didn't save, so I can't just force close this. Yeah, alright. Yeah, if I click check, it's probably going to throw an error. path is helix. The thing being cut is sketch 1. And I'm honestly not sure if it'll let me do this. Sometimes it lets me get away with this. Sometimes it doesn't. And in theory, it shouldn't have any problem with geometry, except that, like I said, this point, well, this will be like basically going up and up over and over again. So this point will be the same point as the next one's version at this point. Yep, and it failed to complete. So what do we do about that? Well, what I can do is I will make another sketch in this plane, and I'll convert this again, and I will not convert that again. Still got that to look at, but I'm gonna actually just draw on top of it. So parallel, 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 and I will go 0.0001 millimeters. And then, hopefully, it lets me get away with it this time. So, I do a swept cut, and I want this, and then I want my helix. And let's see if it lets me do it this time. I just redid this computer, and then I got a Windows update that it's been going so slow ever since. Oh, come on. That's my path, right? Helix. Okay. So I'm going to cut that. And let's hide this helix and hide this plane. And do a sketch. And let's see. Let's show this one. I can do a concentric on that. I can hide that again. And let's see. Show this. Coincident. Hide this. I'm going to offset. Just set it to 1 for now. Reverse it and say 0.0002. And extrude cut through all. Alright, I've got my thread pattern. It's not absolutely ideal, but it'll work for these purposes anyway. So now let's unhide this original one. I'm going to do a combine add. And there'd be a hole down the center of this, but I don't care. There'd be barbs up here. I don't care. This is enough for what I'm doing. So I've got bucket, I've got fitting, new part, new assembly. And close that. I'm going to save right away. And let me insert the bucket. I'm going to insert the fitting. I'm going to rotate this fitting around and around. And need to throw some constraints on there. So if I constrain to this, that should work. Alright. Drag it back out a little bit. And let's see. Can go into here. Actually, no, I don't need to go in there. I can make a plane right out here. So let's say I make a 3D sketch. And I make a line, and I make it up to there. And I've got this plane, so I can go on plane. There we go. And let's see, I can go right from the midpoint. Say these are perpendicular and equal. Now this can rotate all the way around. So how do I deal with that? To lock it down, well, I can go parallel. Parallel. That locks it down. Select this line and this point. Do a plane and OK. And get out of the 3D sketch on plane. Then select the plane again. And I'm going to offset it. And I only need to offset it a little bit. This is just the distance that the bottom of this fitting will be from the bucket. And I just need like 2 millimeters for the part on the outside. So that's all I need to do there. So I'm going to take that sketch, or that outside plane I just made, and that. I'm going to mate those. So that fitting is pretty well locked down, except for that it can move up and down. And how can I deal with that? Let's go back into the sketch. And let's see, this is the flats. Actually, I'm going to add one more thing to this fitting, just to make it a little bit easier to see what I'm designing. So that was the flat. And let's say this is just horizontal. And I'm going to extrude up to this surface. And now it looks a little bit more like that it actually does in real life. All right. So it's vertical. Yep. All right, that's more what I wanted. Go back into this sketch, and I'm going to draw a line from here just down to there, and draw a line out here. This line, parallel, equal, and then dimension, and just want a safe distance of 5. That's good. And then I'm still not done with that, because I want to draw a line going out this way. Oh, that wasn't quite what I wanted. So I'm going to draw a line, and I'm going to go tab to get it to go kind of outward. I'm going to grab one of these planes and that line and say normal. And just to be fully confined or fully constrained, I'll say equal. Not that it really matters how long that is. And then take that line and that point and mate them. And that is now locked down, so I can hide this 3D sketch. And I'm going to save. All right, so that is basically the thing going into the bucket. And then I need to actually start modeling a new part. So I'm going to float this part, and I'm going to say origin and origin are mated. And then I'm going to select it and click Edit Component. Everything kind of turns to glass. I want to grab this face, say sketch on there. And I'm going to make a circle. It's concentric. And I'll go all the way up to here, tangent. And then I'm going to extrude up to surface, which will be this surface. And okay. So right now, if I go into this part as it is, I just have a cylinder. Very basic. But what I can do is edit this component and use this cavity feature. And the first thing I'm going to do with that is I'm going to cavity this. And okay. And yep, it's going to split that in half. So now if I go in here, it's been split. And it wasn't split entirely perfect because I'm at the edge of the bucket. So I will go ahead and say, yeah, I can't do a sketch on that because of the shape. I will have to get rid of this somehow. And it's not, these look the same on either end, but they're not. So let's see, what can I do to get rid of that? Let me try a 3D sketch. And if I convert this, I'm guessing this is a spline. It sure is. And that makes things extra special and fun. Alright, well, I could cancel that. So I'm going to offset this by 0 and hide my bodies. Select this edge, say untrimmed surface by, I don't know, 20, 30, 100. Okay, it doesn't want to untrim that. Fine. Let's try extending it. And want same surface. Distance doesn't have to be very far. And let's show my bodies again. I'm going to select this plane and say split. Selected bodies is this one. I'm going to cut it. And yes. And now should have, so I've got that body, I can hide that. I've got that body I can hide. This body is gone. The surface I don't need anymore. So we got rid of that little extra bit that we didn't need. Alright. And I'm going to close this. Yes. Yes. And I'm going to save. I'm going to edit this component again. And I'm going to do another cavity. And this time, for now, I'm going to leave it as it is. And let's open this back up. So now I've got threads going through into there. And let's see. On this side, I don't need to worry about that spinning. It'll just kind of lock in place, and even if it did spin, it wouldn't matter. This side, it's screwing into, so even though it's got a little bit of help from spinning, it's probably still going to want to spin a little bit. So what I'm going to do is just add a hex to it. And if I bring it in as much as I can, I'm going to say a tangent, and then we'll just remove the tangent right away, just because I want to see where my starting point is. 40 millimeters. That is on the large side. I don't know if I have... well, no, I know I don't have any wrenches that big. Yeah, that's... Even then, I don't have any wrenches that big. So I guess it's just going to be an adjustable wrench or something, so it might as well be, yeah, tangent. And that's horizontal, why not? I'm going to convert this. and do a for construction and offset it by 0.5 inwards. And I'll extrude boss up, and 10 millimeters is definitely too much. 5 is not enough. That'll work. All right. And let's see, what else should I do here? Only other thing I want to do is I want to have a little bit of open space at the end. So let's do a concentric. And let's see, where does this spiral end? It ends right there. So I'll do a coincident for construction, offset by 0.5 is fine. Just do an extruded cut of 2. So that just gives me a little bit of an open space at the end. And at that point, it's looking good. So again, I'm going to go back here, click save, go back into this part. Oh, not this part. This part. And just going to throw, no, I don't need to do that actually. I'm going to hide this. Or, no, I'm not going to hide that. I'm going to delete one of them. And I'm going to say File, Save As. Oh, I should do one other thing first. So, right now this is going to be really tight fit to get over. And especially since my 3D printer always prints circular holes a little bit too small. So, offset by 0.35 divided by 2. And extruded cut through all, only applying to this body. Just to make it a little bit easier. Alright, so then I can delete this, and I'm going to save this as alright, and edit this feature, change it to keep. Alright, and then I'm just going to delete that feature. And then go back to this, to the assembly. Yep. And let's go back to this cavity. And I need a coordinate system. So let me get into this part. And let's see, got up there, got there. I'll make a plane equally between them. And got this and this. So if I've got that, and I've got that, let's see if I've got a coordinate system. So I've got okay, fine. So I need to draw on a couple more axes. That's perfectly fine. So this plus that is this. And this plus that is this. And I have 3 axes, and that should let me do a coordinate system. 1, 2, 1. Okay. And some reason it didn't. Interesting. Oh, I think I need a point, which I hardly ever even use. So there and there. Scroll down, bring this down below my point, then edit this. So axis 1, axis 2, axis 3, and my point. There we go. Now it's where I want it. So I can hide all this construction geometry. I was just trying to get that axis. And I close this and save it. And yep. Now, let's go back and edit this component. Cavity. And I want scaling about this coordinate system if it will let me. All right. And say 1%. So this is a little bit bigger now. The threads are a little bit bigger. Darn it. Did I save that as an STL? No. Alright. My mistake. So I had to do that. I messed that up a little bit. I saved that. It did a save as. I was going to do it as an STL, and I didn't. Alright. Yeah, and it won't let me actually do that. Alright. Regroup. Yeah. So let's edit this cavity. It's gonna be 0. Okay. Go back into this part. Go in here. Going to offset that by 0.35 divided by 2. Enter. Extrude cut through all. Only applying to that one. And save this as just give it a quickie name. Then I can delete this here. And I'm going to save it as an STL. All right. I didn't tell you to open it. It might have. So let's change that around. Say this is save as thread side 0%. And it's also going to be an STL. And actually, go to part, just save as, and then STL. Yep, that's what I want. Why in the world is it opening things even when I tell it not to? Well, that's an interesting little bug. So I specifically told it not to open this. It wasn't even an option unless I went to part, but so I went to part and told it not to open this, and it did it anyway. Or it's doing it very slowly because it's an STL, and STLs take forever to load. Alright, gotta do some diagnostics, I guess, whenever this loads up, which is probably gonna be a while. Alright, solved that issue, and it's still a bug it looks like, but at least that particular issue is resolved. So I'm going to go back to this cavity. So I set that as a 0. So now I'm going to set it as a 1. And go back into here. Do a save as. STL. And call it 1%. And yes. Go back here. Edit this cavity. Edit this cavity. Call it 2. Go in here. Save as. An STL again. And basically going to kind of do that over and over again. I'm going to try 5%. And I'll save it. This one is an STL as well at 5%. And then just in case it's just really not cooperating with me at 5%, I will do one more at 10%. And open that up. And I'm going to save it as an STL at 10%. Close that and save it. Save that and close it. Still got it all in a folder, so if I need to adjust those more, I can. But I've got a couple of parts to print and see how they fit. And I figure I'll probably start with the 5%. If it's too loose, I'll go down to the 2. If it's too tight, I'll go up to the 10. And yeah, that's, like I said, this is not exactly the epitome of high quality design, but it gets me some parts that I can 3D print, and that's all I really need. So that's good enough. Any questions, please leave them below. Supplemental. Made some errors and want to correct them. So first of all, I'm going to edit this cavity. And all right, so I did save that as 0, so I don't need to change that. I'm going to go in here, and I'm going to suppress this. So when I did this part, I made a mistake in that I used a cavity to make this hole. So I got a 27, less than a 27 millimeter because I expanded it afterwards, and that's actually not quite right because it needs to clear the threads, and where it was cavitied there were no threads to clear. So relatively simple fix. I need it to be 27.5 is the hole. And it should, let me just double check with my calipers here. Yeah, that should fit over it quite easily. So I'm just going to do an extrude cut through all and only applying to this. And Then I can delete this body, do a save as, go to STL, and this will be the washer side. Just overwrite the old one. All right, and then I can delete this feature and hit save. Then there was one other thing that, so I printed 2 of these, and they actually do work. I did them at, I used the 5% ones, and they fit perfectly, which my printer is, it always seems to make everything just a hair too big, so 5% is actually probably closer to the 0% modeled, but that's beside the point, kind of. But I wanted to show kind of an alternative way of doing what I did. So, let's see. If I go back to here, yep, and let's say I'm going to save this, because I don't want to save it after what I'm about to do. So I've got this part, and I want to, actually I'll go into the part again, sorry. And I'm just going to delete everything back to this cavity. So still have the wavy cavity. I still have the removed the extra little bit thing there. I don't want to save that. I just want to go back to the assembly. And I'm going to hide the bucket. I'm going to do a file, save as, and I'm going to set it to a part. Give it a really descriptive name. And then I'm going to close this. I don't want to save. I'm going to close this. I'm going to, and open, date modified, temp1. Alright, so now I've got the 2 pieces separate there. What I can do is I'm going to hide these 2. And I'm going to select this face, go to Surfaces, say delete this face. Then I'm going to select this face, also delete that face. That'll give me 2 separate surface bodies, and I don't need this one. And then what I can do is I can take this and say offset surface. And like for instance, I know on my printer that generally it's going to be 0.35 millimeters too big on the inside of a hole. So I can go like that, say offset it by half of that, get rid of the original one, and then open up this, or make this visible, and I can select this, go to split, and then select this body, and cut, and it fails because it doesn't go all the way through, so it's alright. You can hide that, and all we need to do on that is delete all those features again. So sketch on here, make a circle. It's going to be concentric. And look and see where this ends. It's right there. So coincident for construction, offset it by 0.5. Extrude boss, mid-plane by 1. So it goes 0.5 millimeter in both directions. And then I should be able to do this. So I want to delete the face there and there. Delete the unwanted one. All right, so now it goes entirely through, which I should have checked in the first place. Split it, that, and then if I delete this, and I can delete that as well, it's split with that. So that is 0 offset. What if I roll back and I select this and say offset by 0.35 divided by 2, and then I change this split to be using this surface instead. So then I can delete these, delete this, and now that way I've got offset threads as well, just in a slightly different way. So if the cavity method doesn't work for you, or you just want to be able to do it by a dimension instead of by a percent, this is an option for you to use instead. So I could just save this as an STL right now. I don't need to. I already, it worked really well at 5%. Also, I made a couple other things. So in addition to the ports on the sides, I also have ports on the top, an input and an output. So I just kind of made a washer, and there's just a circle with a circle inside of it, and this one made this looks like a circle. It's actually 2 arcs, and they're offset by 2 millimeters this way, and then I've got a 6 millimeter tall text that is wrapped around, just placed on the arc. So I made that, and then I made this just by doing a save as, did a file, save as, and then I selected save as copy and open, and changed output to input. And then this last one, I just suppressed the text. This goes on the inside of the lid. So yeah, that's just all I wanted to show you. I think I'll have probably one more little video segment of actually showing these in place. We'll see. But yeah, that's just wanted to make a couple of corrections and a little bit of an addition, add a little bit more value to the video and a little bit more accuracy.